Having completed my new switch mode power supply, I've now added to it a 12 volt distribution unit. This basically consists of a large number of connectors on the back and some switches and internal fuses for turning on different circuits. My main 12 volt power supply is this 20 amp unit I built many years ago. It's a VK PowerMate. Over the years I've had to add a number of connectors as the number of solid state pieces of equipment in the shack increased, going from valves. Original valve equipment just needed 240 volts, but the solid state stuff, most of it ran off 12 volts, so I just kept adding bits and pieces to this supply. There's quite a number of connectors on the back and quite a number of connectors on the front of all different types. It failed not long ago, and my backup power supply had nowhere near the number of connectors, so I thought, well, the next power supply I build, I need some sort of system that can distribute power to all the 12 volt units, which is independent of the power supply. So I built this box of tricks, which contains 4 XT connectors, XT60s, 4 Anderson connectors, a number of bananas sockets, and some 2.1 and 2.5 millimeter connectors on the rear. I'll show you them in a minute, and some heavy duty 20 amp switches which activate the particular circuits I'm interested in. For example, that one there, the XT20s, and it's actually XT socket 1 and 2, simply because if I had a switch for every socket I'd need a lot more than I've got here. I have 6 switches here, so I've paired up 2 XT sockets, 2 more XT sockets there, and so on. These are the Anderson ones. So I'll just show you a quick look at the back and the inside. So here's the top cover, which shows the circuit diagram of what's inside here. There are a number of fuses on a fuse block, the 20 amp switches, and then these feed the connectors which are on the back. I've also included a combination voltmeter and ammeter. The ammeter is a 50 amp version, so it copes with the expected up to 30 amps through the system from the power supply. So I'll just take the cover off. I've removed the screws. I've actually removed all of the covers so that we can see inside a little bit better. So here's an inside view from the top. Here are the fuse block. It can take up to 10 fuses. I'm only using the 6 at the moment. The XT connectors here, and a number of other connectors on the back. Down here we have the connections to the switch. I'll just zoom in a little bit closer. Have a bit of a look at the fuse block and the rear of the unit, which is just up here somewhere. That's the back of the XT connectors. Now I'll just show you the rear. So here is the rear of the unit. 4 XT60s, 2 on one switch, 2 more on one switch. An input from the 30 amp power supply. This is the male version, these are the female. And then a row of Anderson. I've got 4 there. Again, they're paired off. Down here we have some banana sockets plus banana with terminals, which I sometimes use with just loose wire. And then 2.5 mil and 3 2.1 mils, which I tend to use those on smaller items like antenna tuners and things like that. They're capable of a couple of amps. The XT connectors, of course, are capable of quite a lot of power, so are the Anderson. So that's the rear of the unit. This is a bottom view. All of the earths go to one point here, this circuit board. It's insulated from the case. With a shunt, an ammeter shunt in the distribution system here, the actual earth of all the connections are not the same as the case earth. The shunt is in the negative lead. I'm hoping to remove that shunt and use an ammeter which uses a ferrite pickup coil, and that will remove that problem. But you can see all the earths from all the connectors go to this one spot. There's a bit of filtering here, 4700 mic, 25 volt, and here are the back of the switches. The switches are switches designed for cars and things like that. They run at, they're 20 amps with 6.3 millimeter glide-ons, which is quite handy, and they have an illuminated LED in the shaft, which is also useful. I'll show you the side. Again, the construction of this box just uses aluminium angle from the local hardware store. By doing this, it's easy to actually construct, because you can wire everything up without having to pull things apart. There you see the shunt down the back here. It's 75 millivolts at 50 amps. So it drops 75 millivolts at 50 amps. That's basically how they work. But as I said, I'm going to try and replace it with one which I've ordered, which uses a toroid with a wire going through it, which means there won't be any voltage drop at all. The DC input just comes in from that connector and just goes straight to the fuse block. Then all of the outputs of the fuses go to the switches, and then the switches feed the connectors at the back. That's how it's been laid out. Mind you, if you're building a DC distribution system, you don't actually need all this. You could just put a whole pile of connectors on a block or on a box and feed an input and put everything in parallel. But I thought I would allow myself some switching and monitoring of each of the circuits. So I decided to make this box up with the connectors going through individual fuses and be individually switched. A lot of gear has its own switch, so it's a little bit of an overkill, but I've now connected the homebrew, one of the homebrew rigs, to the output of this box. And I'm just going to turn on the homebrew rig, and we can watch some of the watch the current. There you go. That's the Mark V transceiver. It's drawing 600 and nearly an amp. It's just come on, and I'm going to transmit into a dummy load. I've got a dummy load up here somewhere, and I've got it set for around about, I think it's about 50 watts. So there's a view of the Mark V transceiver tone. It's actually pulling 14.4 amps, 12.4 volts, and it's putting out 50 watts into the power meter. Turn that off. And this is the front of the distribution unit. I'll just key up the transmitter again. So it's showing around 14.1 amps. The voltage at the distribution unit's around 13.1 to 13.2 volts. The voltage at the actual transceiver is 12.4 volts. So we're getting about 800 millivolts drop between the measuring here and the transceiver. There's about 1.5 meters of cable. It's 12 gauge cable, but it does at that sort of current, it's got significant drop. I also noticed that the drop inside the power supply can be up to 400 millivolts, not because of the power supply regulation, but due to the DC filter choke. I found there's about 200 millivolts drop at about 20 amps across each of the coils. So probably at 14 amps, we're probably looking at about 300 millivolts. So we get a drop from 13.6, well, there we go, from 13.6 to 13.2. So we've got 400 millivolts drop, mainly due to the choke. There's 100 millivolts due to the power supply, 300 millivolts due to the choke. So if you can do away with the filter choke, you can save a bit of juice. Alternatively, you need to ramp the power supply volts up a bit more. At the transceiver, the 12.4 volts is quite good enough. And you've got to remember, this is a steady 14 amps. That's not normally what happens with sideband. It's the average current is much less, so it's not a very significant problem. So I'm just going to do a little transmission from the Mark V, and I've got this Mark IV sitting here with the receiver attenuator switched on and dummy load. So I'll just do a bit of transmission there. The switch mode power supply is very clean. Hello, test 1 2 3 4 5 6 7 8 9 10 testing. So that's a sideband transmission out of the Mark V into the Mark III. 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. It's 0 beat somewhere around there. So the power supply is quite good. So knocking the audio microphone straight down and just transmitting. That's what we're getting out of this rig. There's no hum or anything like that. There's nothing on the meter. So there's no noise modulating the system is basically what's happening there. It's quite clean. So that's the end of the demo with this little unit. This is what happens when I turn all the switches on. All light up quite nicely. So I can control bits and pieces of equipment using this little box, and so if I have to change from one power supply to another, all I've got to do is unplug the input from this particular supply and use some other supply. I don't have to worry about disconnecting everything and trying to find a supply that has all of those matching connectors as well. So I think this idea of a separate unit is quite good. As I said, you don't need all the switches, you don't need all the fuses. You can just do it by paralleling all the connectors at the back. We'll do the same thing. But I've chosen to make this little unit with a bit more control and also some monitoring of voltage and current.